So here our domain will be limited from -2 to +2. Our range will be from 0, which is here or there, up to +2. Then we also have our zeros, or our x-intercepts, are at the points -2, 0, and then we have another x-intercept at the point 2, 0. And just to add something else, right, then we have the y-intercept up here, and the y-intercept is the point 0, 2. So that is the point where the function actually touches the y-axis. You will notice on the notes there is now a little spot talking about interval notation. If you look in the folder with this video, there is a video that is just called interval notation. So if you do not know and understand interval notation, you can watch that video. If interval notation is something that you have worked with before and understand, you do not need to watch the interval notation video. Now, you will see the word intervals in the next section of notes. It says that increasing or decreasing intervals. These are intervals of x over which y is either continually increasing or continually decreasing as we move from left to right. A function switches from increasing to decreasing at the top of a hill and vice versa at the bottom of a valley. So what does all that mean? That means we've got this function. Straight. All right, we've got this function, and it can do a variety of things. Functions can go up and then down and then up and then down. And so here's a function, and I'm just going to label some points on this function so that we can talk about it. Let's say that this is the point -1, -2, -3, 2. This is the point -0.5, -3. 1, 2, 3. We'll make that the point 3, 3. And for intervals of increase and decrease, those are all the points that we will need. So, when we are talking about intervals of increase and intervals of decrease, there are a couple of things that you have to keep in mind. Intervals of increase and intervals of decrease are concerned with the x values, not with the y values. So what we are looking for here is, when are we traveling uphill, and we always travel from left to right, right? When are we traveling uphill, and when are we traveling downhill? So it doesn't matter where we are vertically. All that matters is, are we going up or are we going down? So let's first talk about our intervals of decrease. Intervals of decrease. So this is where we are going down. So we start off, we're coming up, 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 up. We get to this point at -3, and then we start going down. So that -3 point, that is the top of the hill. It is not part of the interval, but it is right after we get past that point, that's where we start decreasing. So our interval of decrease starts at -3, not including -3, and then we have all of this as an interval of decrease until we get to -0.5. Again, we never include those endpoints in our intervals. Then we are going to see, all right, so that was one down. Are we going to go down again? So we're going up, we're going up, we're going up, we're going up. We get to this point. So we're going to union this with 3. And then we're going to go on, and it goes on forever. So it's going to decrease from 3 to infinity. There are my intervals of decrease. Next, we look at the intervals of increase. All right? Same rules, except instead of going downhill, we're going uphill. So we have intervals of increase. Put increase of increase. Intervals of increase. So we are increasing here. Then we are increasing again here. So as far as intervals of increase go, we're going to go from negative infinity up to negative 3. Again, do not include the peaks and the valleys. Do not include the tops of the hills or the bottoms of those valleys. We go from negative infinity to negative 3. We union that, and then we come over here, and then we're going to go from negative 0.5 up to 3. Intervals of increase, intervals of decrease. Where are we going uphill? Where are we going downhill? We will use this same little bit for the next piece of our notes. What we see next, we are looking for are maximums and minimums. These can also be referred to as absolute maximum or an absolute minimum. So the absolute maximum and minimum occurs at the highest point. Similarly, a function has a lowest point, we call that a minimum. It is very possible that not all functions have absolute maximums and absolute minimums. So in this case, we see that we have 2 peaks, and we are not going on forever up. Let me actually do that in purple, since I already used. All right, we have 2 peaks. And so the 2 purple circles are the possible possible minimums and maximums. So we look at the y value, and we see that in both of these cases, right, one of the y values is 2, the other y value is 3. So it does not go any higher than that. So the absolute maximum of this is at the point 3, 3. Now, all functions do not have absolute maximums and absolute minimums. So like in this case, because these arrows go down forever, there is no absolute minimum. So we do have an absolute maximum, we do not have an absolute minimum. But the other thing that we talk about, if you continue to look, is the idea of relative minimums and relative maximums. So once we've identified the absolute maximum, that is not a relative maximum, right? That's the absolute maximum. So we're only going to label that once. Over here, since this was a potential for the absolute maximum, for this is a peak, we now know that this is a relative maximum. And down here at this negative 0.5, negative 3 point, even though there's no absolute minimum, this, because it is at the bottom of a valley, this is a relative minimum. Now, the next thing that we see on the notes is this idea of being well-defined points. The point actually has to exist. Maximum minimums may not occur where the function goes to infinity. So that's why we said we do not have relative absolute minimums in this case. We will talk later about what is called an asymptote, and that's a place where the function does not exist. Again, if the function doesn't exist, it can't have a maximum or minimum at those points. These relative minimums, relative maximums, absolute minimums, absolute maximums, these are all well-defined points. These are actually points that are on the function.